Okay, welcome viewers. So in this video lecture, we want to cover this topic that what is a proof strategy. There are basically different types of proof like direct proof, contradiction proof, okay, or contradiction proof, and then we have contrapositive proof, vacuous proof. So these proofs we want to see one by one. Okay. So in today's class we want to cover this direct proof. Okay. Suppose that you are given one statement P and you want to prove that if you have this P statement then the Q statement is also true. So this is called the direct proof. Mean you start with this P statement and then you prove that this statement Q is also true. So this when you solve your question like this, then this is called the direct proof strategy. Okay. So we have one question in our hand which we want to solve. So the question is this that give a direct proof to of the theorem that if n is an odd integer. Okay. So here the P statement is this that n is an odd integer. Okay. And what is the Q statement? Q statement is this that n square is odd. Mean we want to start our question from this statement and we want to prove that this is also true. Okay. So uh, proof. Now as n is an odd integer. So every odd integer can be expressed like this form 2k plus 1 where k is an integer. Okay. Every odd integer can be expressed in this format. Okay. Now we want to find n square. So n square mean 2k plus 1 whole square. Okay. So what it is? This is equal to a square plus b square plus 2ab. So this is 4k square plus 1 plus 4k. We club these two. Okay. So here we get 4k square plus 4k plus 1. So from this we can take 2 common and here you are left with 2k square plus 2k. Okay. As k is an integer, so k square is also an integer. So ultimately you can write it as 2 times m plus 1 where m is equal to 2k square plus 2k which is an integer. So you have expressed n square in this form 2m plus 1 which is the form of an odd integer. Okay. So it implies that for all n, okay, this pn statement implies the qn statement. Okay. What does it mean? That whenever n is an odd integer then its square is also an odd integer. Okay. So we have proved this thing. Okay. uh, Now we want to solve the next question. So see the next question. The question is this that give the direct proof that if m and n are uh, both perfect squares, okay, then m into n is also a perfect square. Now, what is the definition of perfect square? A is a perfect square if we can find one integer b such that a can be written as b square. So what is the P statement here? P statement is m and n are perfect squares and we want to prove that their product is perfect square. Okay. So now as m and n are perfect square, so m can be written as a square and n can be written as b square. Okay. Where a and b they are integers. Okay. Now what is m into n? M into n is a square into b square. So this can be written as a into b square. Now as a and b are integers, so their product is also an integer. So m into n has been expressed as the square of some integer. So it means that m into n is a perfect square. So you see that it is very easy to prove this thing. Okay, that when m and n they are perfect square, then m into n is also a perfect square. So this is the another example of direct proof. Thank you very much, viewer, for watching this video. More about it will be discussed in the next video lecture. Thank you very much.